Next up is Jordan from the University of Wisconsin. He's going to be talking about the challenges in learning, understanding developers writing DevOps artifacts.
Thanks for that introduction. I'm going to talk to you about some work I did this past summer at MSR with my collaborators, Chris Bird, Shivendu Lahiri, and my advisor, Tom Reps. So before I really dig into things, I want to just get us on the same page really quick about what I mean when I say DevOps. I'm mostly going to be referring to two things, DevOps tools and DevOps artifacts. When I say DevOps tools, I mean tools like Docker, Jenkins, Travis, CircleCI, that sort of stuff. And one thing I'd note about these DevOps tools is that most of them take some sort of input configuration, a Docker file, a Travis file, a Jenkins file, etc. These input files I'm going to refer to as DevOps artifacts. So we have DevOps tools, think Docker, and we have DevOps artifacts, think things like a Docker file. I want to assert that DevOps is popular. Hopefully I don't have to convince you, but maybe I do. So here's a kind of a ranking of results for a bunch of different repositories on GitHub, actually all the repositories with 10 or more stars up to like June 1st of this year. And if you look at breakdowns of what languages do these repositories use, and you treat DevOps artifacts, those files, as a language of sorts, you'd find that about 1 in 4 of these popular GitHub repositories are utilizing DevOps artifacts. This was a sample of like 900,000 of these repositories, so that's nearly 250,000 that we could maybe impact if we can provide good support for DevOps artifacts. The problem I want to dig into is the fact that for these popular languages like C# and JavaScript and C, you have good support in your IDE, right? If I make a mistake in something like VS Code, I'm going to find information about that mistake ahead of time. Whereas for Docker, there's a Docker language plugin for a lot of IDEs, but it doesn't tell you much. It gives you syntax highlighting, and you can't see it in the slide, but if I mangle the syntax, if I mangle the embedded bash in the file, it has no idea. It doesn't have deep semantic support. So that's kind of what we're looking at here. How could we make support for DevOps artifacts better? And in particular, we're going to focus on Docker just to kind of narrow things down. So we introduced a tool that we call Binnacle for learning from and supporting these DevOps artifacts. It operates in 3 phases, the first of which is phased parsing. Okay, we're going to need good structural representations of these artifacts if we want to do things like rule mining. And if we can do things like rule mining, well, then we could write a static analysis in kind of 1, 2, 3. We parse things, we learn rules, we apply them. We've helped you write better DevOps artifacts. But there's no free lunch, right? There's challenges in each of these areas. How do we deal with all the nested languages in a DevOps artifact? It has simple declarative top-level syntax, but there's a lot going on underneath the surface. There's prior work that just says for Travis files, you can't mine these, which might be problematic for us. And then there's also the fact that if we want to provide semantic support, we need to figure out how to do it. So today, I'm going to give you a whirlwind tour of this phased parsing, how exactly we do that, how we deal with the problem of nested languages, and kind of progress we've made in that area. Because if we can do that, if we can get good structured representations, we can mine rules, we can write good analysis, all that kind of good stuff will follow. But before that, we had to get data. So there's this crazy infrastructure that we use to get a lot of data. I'm not going to talk through that. I'm just going to talk about the big blue circle, which is about 250,000 Docker files that we extracted from GitHub. So that's the whole point of this little exercise. We have a bunch of Docker files. We did all the stuff like deduplication, looking at them, making sure they parse, all that good stuff. But that's kind of the sample we'll be working with. We have some other interesting data sets that you should definitely ask me about offline, but the big blue circle is where we're at for this talk. So nested languages, what do I really mean when I'm talking about this? Well, at a top level, for a thing like a Docker file, you have this simple kind of linear declarative syntax from this image, do this thing, do that thing. And I guess for context, Docker is all about setting up an environment to run your code in. So this top level syntax is all about the steps you need to set up the environment so you can run your app. Inside that, you have embedded shellcode, which is kind of icky. And then inside that, you have these popular CLI commands like git, apt-get, curl, make. You have Python, which could have Python embedded within it. You have things like GNU's find that has more crazy syntax, and then maybe bash within that, and the exec clause. So this is a big mess, right? There's all these nested languages that kind of go all the way down. We need to figure out what we're willing to deal with in this area. So parsing the top-level structure is easy, and pretty much everybody does it. Parsing the embedded shell isn't fun, but it's doable. Parsing the options language of Git is just a giant mess, right? So what we decided is we'll do the top level, we'll do the second level, and we'll let the data drive how many of these specific commands we support by looking within their options languages and extracting structured information. So in this case, we took the top 50 because it gave us nice coverage. And then when you go further on this list, we're just going to ignore it. There's only so much you can do. And these 3 steps is already going to get us a lot more structured information than other tools are working with. How do we actually parse for these 50 different commands? We wrote a parser generator. We made 50 schemas for 50 different commands. It was not really fun. And then how does phase parsing actually work? What does it look like? Well, here I've shown you just the top level syntax of a Docker file parsed into an AST. There are these nodes I've circled in red, these unknown nodes. You can think of them as string literals that have further structure we could discover if only we parsed within them. So that's what we do in the second step of phase parsing, right? In phase 2, we parse within the embedded bash. But again, we're confronted with more of these nodes like apt-get install foo that have more structure that we just aren't aware of at this step. So then you bring in those 50 generated parsers, and you get even more structure. And then there are some things, some specific commands that you might not get structure for, and that's just that. So some really quick results. On average, there's a bunch of these unknown nodes, these effectively uninterpretable nodes that you can't look within at phase 1. At phase 2, the distribution gets tighter, but there's still a lot. Actually, in specific cases, it can go up, which is a little counterintuitive. And phase 3, things get oh so much better. And that's that. So phase parsing, that's something we did to enable these other two things. I won't talk about the other two things, but ask me offline, because we have cool results in actually mining rules from the data and using them for analysis. And kind of for the future going forward, we see this tool in a bunch of different places, in the IDE, in the language server, in an automated pull request review bot, all kinds of cool downstream applications. But thanks for listening, and catch me with as many questions as possible.
So one thing I was missing was some intuition for what kind of errors you hope to capture with the static analyses.
Yeah, so for DevOps artifacts, the kind of bugs or errors you get, they're not really breaking things, right? Because if you break your DevOps artifact, you can't deploy, you can't build, et cetera. So really, they're kind of code smell-esque things. Like in a Docker file, you might apt-get install a bunch of things, but forget that you should remove var cache lists or whatever, or forget that you should use the no install recommends and have some sneaky dependencies you're not aware of. So they're not, don't think of them as like big breaking bugs. Think of them as kind of a code smell-esque sort of thing.
So a lot of these DevOps artifacts aren't checked in directly to repos. They're sometimes generated with other scripts or with programmable configuration languages. Does your work support these sorts of DevOps artifacts? And if so, do they exhibit any differences with like typical DevOps artifacts that you've noticed?
That's a great question. We're sourcing our data from GitHub, so we're only finding the checked-in ones. I would say as of late, there's definitely a trend to have a lot of these things checked in and version controlled for things like Docker or Helm charts in Kubernetes or Travis files. But you're right, there are a whole class of DevOps artifacts that might not be, and we don't really explore those. So, thanks. This is free.